Okay, so yesterday's problem of the day said, which travels the farther distance, an object that starts from rest and accelerates at 2 meters per second squared for 6 seconds, or an object that starts from rest and accelerates at 6 meters per second squared for 2 seconds. And it looks like I just gave you a multiple choice with option 1, so probably had a hard time answering that. I'm sorry about that, but we can go over the problem now, and I'll change this so you can upload your answers afterwards. I didn't realize that. Okay, so we'll start as always with our given information, right? What do we know? What do we have for givens here?
2 meters a second for 6 seconds.
Okay, so what givens are those?
The given for object 1 and the other given for the second object.
Yeah.
Velocity.
And we've got velocity. Okay, so that's a good point, right? We have 2 different objects here, so we got to make sure we keep track of which given goes with which object. Right. So let's talk about object 1 first. Right, the first object there, the one that starts from rest and accelerates at 2 meters per second squared for 6 seconds. Right, we know they both start from rest, so I'll put that the Vxi equals 0. So object 1, what are the givens for object 1?
2 meters a second for 6 seconds.
Yeah.
And it starts from rest, so 0.
Okay, so 2 meters per second squared. Which quantity is that? How should I label that one? Is that the temperature?
Acceleration.
What is it?
Acceleration.
Acceleration, right. So we've got an acceleration that's 2 meters per second squared. And then the 6 seconds, what quantity is that?
Time.
Yeah, time. Good. Okay, so that was the first object. The second object also starts from rest. But what should the givens be? They're a little bit different for object 2, right?
Mm-hmm. So we got 6 meters a square for the acceleration.
Right, 6 meters per second squared for acceleration for this one.
And for the delta time, we got 2 seconds.
And the delta t is 2 seconds. Right, so close, but not exactly the same. And then what is the unknown for these? What are we trying to find?
For the distance.
We want the distance, right? We want the distance for each of them. And then we'll compare and see which one went farther. So it looks like we're going to be able to use the same equation for each of these, right? We have the same quantities, Vxi, Ax, delta t, and delta x. So which equation would I want to use to figure out how far each of these objects go?
The third one.
Yeah, the third one's going to do it, right? Because that's got Vxi, Ax, delta t, and delta x in it. So I'll copy down the third equation. And it looks like we don't need to rearrange anything today, right? Because we've got the unknowns all by itself on one side of the equation, delta x. So we'll just plug in. So first for object 1, my delta x is, well, the Vxi is 0, so Vxi times time is just 0. And plus 1/2, this time the acceleration is 2 meters per second squared. Oops. And the time is 6 seconds. And remember, the delta t squared in the equation, so we have to square that part. So for object 1, we get a displacement of 1/2 times 2 times 6 squared, which is 36. And my units are meters, right? Because I got meters per second squared times seconds squared, just leaves meters. For object 2, right, my Vxi is still 0, and I get 1/2. This time it's times 6 meters per second squared times 2 squared, 2 seconds squared. And so that's a little bit different. This time I square the 2 instead of the 6, so I get 0.5 times 6 times 2 squared equals just 12. So for object 2, I get 12 meters. Right, so clearly then object 1 traveled farther. Right, because it traveled 36 meters instead of 12. Any questions or comments on that? How we got any piece of that?